Hello, my name is Victor Eduardo Peña Montes. I am in class MECH 1321 in the fall 2020 semester with Dr. Calvin M. Stewart in the Department of Mechanical Engineering at the University of Texas El Paso. This is Project 2, the Mars Lander. Project 2, the objectives. This is a nice image provided by Dr. Stewart, which I really liked. That's one small step for eggs, one giant leap for egg-kind. Neil Ekstrom. Now, the objectives. In this project, we will use what we have learned throughout the semester to perform the following. We will figure out the velocity of the lander that we have created, as well as the forces, and of course, we will achieve the successful lander. The objective statement. We have been challenged to both design and construct a Mars lander. In said lander, we are to introduce an extronaut that is secured within the frame of our design. This lander will be made of spaghetti or any commercially available pasta. It must not exceed 450 grams in weight, which of course includes the egg itself and any accessories, and must be capable of withstanding a 1 meter drop. Now, the design requirements. This is another diagram provided by Dr. Stewart, which showcases the 450 gram, at least 450 gram weight lander in the 1 meter drop, as well as the landing pad size, which is 300 millimeters by 300 millimeters. We are to follow the following requirements. Of course, the minimum drop height, which is of 1 meter, the maximum weight, which is 450 grams, the max landing pad size, which is 300 millimeters by 300 millimeters. The lander cross-section must not exceed this surface area. Glue can only be placed at the joints, not along the members. We cannot paint the lander. However, the external can be decorated freely. We must now do brainstorming sessions to decide what would be the best lander design for our extronaut to perform his mission. In order to decide what type of pasta lander would be the most optimal one for our extronaut to survive a 1 meter drop, it was not an easy task. I had to do research in order to obtain information and decide what would be the most optimal. Starting off, I first decided to see what were the landers that achieved success when landing, looking first at the Phoenix Mars lander. Looking at the Mars lander, I sketched a design using the decagonal shape that it had. However, during drawing the set sketches, I got the idea to use the design from the bacteriophage, since I thought, yeah, this could work. Thus, I started my research on the bacteriophage design and concluded with the following design, which is the one shown at the left. You can see the decagonal shape as well as how it would have worked out with the trusses. However, as I continued and started prototyping, I realized that it was not gonna work, since it consisted of way too many small sections that I inferred that would fail almost immediately and decided to stop production on it. This is what a bacteriophage would look like, as you can see, it has too many small sections. It would have been needed to create a design that is too different. It wouldn't resemble a bacteriophage, which wasn't what I was looking for. So, in our next brainstorming session, for my second prototype, I was not sure what I could do for a second prototype. So I took inspiration from online designs, and this one specifically caught my eye. This design is triangular, and what caught my eye was that the strands go over and capture the egg in its snug area, which makes it tight, as well as it forces it to never touch any the ground. Following is a sketch over my prototype. In mine, I added legs, so the impact will be on them rather than the body itself. As you can see, the eggs as well as landing pads. However, I did not get far with this design, since I did not deem it as being able to make it work. So I simply modeled it and placed the egg inside, which looks something like this. You can see the egg inside the triangular design that I made. So for our next brainstorming session to decide on a third prototype. For my final design prototype, I opted for a simpler design. I went with a cube connected by simple trusses and reinforced with lasagna walls. On the left are segments that are made up this last prototype. On the very left, you can see the truss itself, the strand of spaghetti. On the bottom right, you can see the truss joining one of the walls of the cube. And on the very top, you can see the cube wall finished with this lasagna wall. After finishing up some touches, I finally added the final touches, which were the last walls to reinforce it, as well as the final trusses to make it much sturdier. To the left is a finalized idea of what this further should somewhat look like. It still has some work needed, but that will be revised in the final design. You can see how it would have looked like. However, that one was too messy, so I decided to make another prototype. I also made a prototype with legs. However, this one did not get far since the legs kept on breaking off. And since I didn't wish to harm the main body, I scrapped the legs. You can see that the legs weren't very sturdy, even with trusses. So I just ended up not placing them on the design. So for our final design, this is what I decided to go for. I made a mix of two of my sketches, both of them being the triangular design and the cube design. The cube design being mainly for the body, and the triangular design being for the reinforcement for the egg, so that it had something to rely on rather than just the cube. Below are the inspirations from the triangle design from a previous sketch. You can see in this one that I actually modeled the triangle based on the egg rather than previously just making a triangle and trying to fit the egg in it. I also thought of using this ribbon on my triangle design. However, I was not sure if I was gonna be able to use it since I wasn't certain that it would fall under the criteria that we were given. However, this is what it would have looked like, and it would have provided much more support to the egg. However, in the end, I just ended up scrapping it due to not knowing if I was going to be able to use it. Now, this is the triangle design in its weight, which is going to be 88 grams. This is the cube itself with the bag added, which is going to be 185 grams. This is how it would have looked like, both of them together, the triangle and the cube design, weighing 275 grams. This is the cube again itself with the bag added and tied up. This is the final design again. However, I would like to point out that it wasn't glued together. I added the triangle on top of it, so since I felt it would have much better impact, it would absorb the impact much more better that way. Now how to calculate the velocity. For the velocity, we use the simple formula of velocity squared equals the force times the height over the weight, which is going to give us, inputting the values, velocity squared equals 2.71 newtons times 1 meter over 0.276 kilograms. Simplifying, we get velocity squared equals 9.81 meters. And simplifying even more and getting rid of the squared, velocity is 3.13 meters squared. Now, for the calculation of forces, it was very easy, thankfully. The normal force, which is going to be force equals mass times gravity, is going to give us 0.276 kilograms times 9.81 meters per second squared, which for the normal force, we will get 2.71 newtons. Now for the potential energy, we must use the mass times gravity times height. There's going to be 0.276 times 9.81 times 1, which is going to be 2.71 joules. Now, the kinetic energy is the same as the potential energy, so it's going to be 2.71 joules as well. Following up is the video. This here is the lander that we will tested and that we will drop from a meter drop. In this part, I am not sure what happened when trying to transfer the video through the editor. This part kept on freezing up. I tried 5 times, around 5 to 4 times, and this part kept on freezing up. I even tried recreating the video again, so it's gonna be just that. However, that first trial did end up failing. Hello, my name is Victor Eduardo Peña Montes. I am in the class MECH 1321 in the statics course with Dr. Stewart. This is my credential, covering the numbers for obvious reasons. And today I will be presenting Project 2, in which we were tasked to design a lander entirely made of pasta, in which we will put in an astronaut that's going to fall, a 1 meter drop, and it will survive the fall. I am now setting up the parachute so it will have an optimal fall. This is the lander itself. Inside there's the egg. Now from the ground up to the marker, it's around 1 meter. But just in case, I will be dropping it a little bit above to ensure the meter drop. I will not drop it. 3, 2, 1, go. As we can see, the seat for the astronaut broke. However, the astronaut is still safe and sound. 2, 1, go. 2, 1, go. Go. So in conclusion, we managed to create a design that was partially successful, but successful nonetheless. It was a lot of fun creating this lander, as well as a lot of fun for me since my family were very helpful, providing me tips throughout the making of it. Thank you so much for your attention and have happy holidays.